All right, good morning, everyone. Today we solving lead code 124, binary tree maximum path sum. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can directly appear in a sequence at most once. Note that the path does not need to pass to the root. The path sum of a path is the sum of all the nodes' values in the path. Given the root of a binary tree, return the maximum path sum of any non-empty path. So in this first example here, we can see the output is 6 because that is the maximum path sum. And the correct path would be from going from 2 to 1 to 3 for a grand total of 6. And this works because it does not violate any of the rules. We did not use any nodes more than once, and all pair of nodes in this path are connected by an edge. All right, let's look at another example here. In this example, the maximum path sum would be from 15 to 20 to 7. And that would equal 42. And it's because we don't want to include the root because that would add negative 10 to our maximum path sum that we found so far. So that would decrease it. So we want to make sure not to include the root in this example here. All right, so I drew out the example. And the first idea is that we're going to use a depth first search algorithm. And what we want is at each node, we want to return what is the maximum path sum that we could find so far and return that up to the parent. So in this example, let's say we're at the node 20 and we want to return what is the maximum path sum that can be found so far. So it's either 20 plus 15 for 35 or 20 plus 7 for 27. And that's what we have to return up to the negative 10 because we can't choose both of these, right? This is an invalid path because how can you traverse all of these nodes without going back? Let's say you start at 7, you went 7, 20, and if you go 15, you can't go back to 20 because you can't use a node twice. Therefore, we have to choose what is the optimal path from 20 if we want to return up to its parent 10. It would be like this if we're returning up to its parent. We can't include the 7. So hopefully that makes sense, and if it doesn't, like, make sure to rewind the video. But the overall gist is whenever we have to split up the path, we want to pick the most optimal way because we cannot go both. All right, so the key idea here is we're going to use depth first search on every single node. And when we reach a null node for our base case, we'll just return 0 because that there is no node there. So that's how we tell the computer that there's nothing there. So add 0. And we want to have a res variable that's going to keep track of the maximum path sum so far until we've traversed all nodes in the tree. All right, and we just return up to the parent with the max we've seen so far. Perfect. So we're going to quickly, let's say we went from negative 10, we went DFS node.left, and now we're at the 9. DFS node.left again. This is null, so it would return up 0. DFS node.right, it would return up 0, right? Now, since the max of 0 and 0 is 0, so all we have to do is to 10 is just return up the 9, because that is the maximum path that we could find on the left subtree from negative 10. So it returns up a 9, right? And so far, our maximum path sum that we found would be 9. Because we haven't traversed the rest of the tree. So far, we found a 9. So that's the max we have so far, all right? Now, we have to go DFS node.right. We go to the 20. We go to the 15. We go to the null pointer. Of course, this returns up 0. We go to the right. Of course, this turns up 0. All right. So now 15 is going to return up 15 to its parent 20, right? Because this is the maximum path sum that can be found from 15. So that brings up our res because we found a 15 and that's greater than 9. So the max we found so far is 15. So 20 gets a 15 from its left-hand side. And now I have to go right. And I'm sure you can imagine what happens here. It goes 0, 0. So all this would do is just return up 7, right? So 20 gets a 15 and a 7, right? And here's the thing. We say, all right, sorry, so what do we return up to the 10? Here's the really, really interesting part. You have to pause, and it's okay. We have to stop and think about it. This is a valid path. It doesn't have to pass through the root. So at every node, we check if the current path sum is greater than our res and put it in there. Just like how we found the 9 here, and that was the max path sum at a point, and the 15 was, even though it didn't pass through the root. So since we're at the 20, we say, all right, its left-hand child is 15. Our current node is 20. 20 plus 15 is 35. And then we say, what's the right-hand side? It's 7. So a grand total of 42. That's greater than 15. So we just add that there. And we'd say, all right, this is the current maximum path sum that we found that doesn't pass through the root. But if we want to pass through the root, then we can't choose both. So we have to choose what is the greater option. So we say 15 plus 20. And we pass that up to the negative 10. So that would be 35. Hopefully that makes sense. And the key idea here is that when you're at a node, you can choose the right and the left. But when you pass it up to the parent, you have to pass up what is the optimal path. Because from 10, if we include this 10, right, we can't go 20, 15, and then 7 because we'd have to repeat nodes. There's no singular path that can go and touch all of those nodes. All right, so hopefully that makes sense. And that's why we would return 42 because we get up to the negative 10 and negative 10 would check its left-hand child and see, hey, what's negative 10 plus 9? That's 1. Then we see the right-hand side has a maximum path sum of 35. So we say, all right, what's 1 plus 35? That's 36. 36 isn't greater than 42, so we're just going to return 42. All right. And there's a counter example here. Let's say we had a node, like a binary tree like this, and we had like 2, and then we had a negative 1, right? If we went DFS node.left, it would hit the null pointers and return up 0, right? And what do we return up to 2? Well, we say left, what's the maximum path sum of left and right? It's 0, and then plus negative 1, so that would mean subtract negative 1. This would return up negative 1, right? If we ever return a negative number to a parent, we should never use that because that would always lower our overall path sum. So if we ever get a negative node or a negative value, we just want to default it to 0 because the maximum path sum would just be having the 2 all by itself. But in our current approach, we would just have negative 1 minus the 2, which would be incorrect. So that's why we don't want to do that. All right. So now we went over the problem. Let's go over how would we solve something like this. So first I like to use res. And since we're using the maximum path sum, we want to make sure that we use a really small number to start. And it would just get bigger over time. So I used to float negative infinity. So just make sure we have a really small number. Next, we want to create our function. So define function, DFS, and we want to include a node. Next, we want to create our base case because this is a recursive function. So we say, all right, if not node, return 0. Left equals DFS node dot left. And whatever we do to the left side, we have to do to the right side, right? So if we don't hit a node, we return 0. We store the left-hand subtree in the variable called left and the right-hand subtree in a variable called right. All right. Now let's say, what if left or right equals something less than 0? So I say left equals the max of 0 and left. So this is to ensure we don't return up any negative numbers because a negative number would decrease our path sum. So it would be more beneficial to just not include it. So this is how we tell our program to do not include a negative number. So if left or right comes up to anything less than 0, this will make sure it defaults to 0. All right. Next, we want res to equal the path that we found so far. So res equals the max of res, so whatever the old value was, and we have left plus right plus node dot val. And if you remember here, let's say when we were traversing this tree and we were at the 9, left would return 0 because that's a null node. Right would return 0, so that's a null node. So we want to return up left plus right and the current node. This would be the current maximum path sum. And then when we return what is the max of the left and right path. In this case, they're equal, but like let's say we're at the 20, we want to return up the path going from 15 to 20 if we're passing it up to the parent node because we can't go to both, right? So this line just makes sure that we're looking at the current path sum if it doesn't include the parent. And if it does include the parent, we're going to have to say return the max of left, right, node dot val. All right. Just to quickly reiterate this first line here, make sure that we always capture paths that might not pass through the parent. So if we're at this 15 or we're at this 20, we want to make sure we grab the 15 and the 7 because it's a valid path. But when you have to return up to its parent, we can't bring both paths because there's no way to travel to all 4 of these nodes without repeating. So that's why we want to return up what is the max from the 20, either the right or the left. So we'd go 15, 20, and then to negative 10. All right. So that's what these two lines do. Next, since we're reassigning res, we have to make sure that this function can see res. So we use non-local. So non-local res. So this allows us to change the value of res from within inside this function. And now all we have to do is call our DFS function. So we say DFS root and return yes. All right, and let's run it. Let's see what happens. There we go. And we passed the problem and it's relatively efficient. So I hope you learned something new. If you have any questions, please comment down below.